Alright, so today's notes are a little bit different. We are doing 6.3, which is fitting square root functions to data, but it's, for lack of a better word, weird. So I'm actually basically going to do our notes as just examples. It's the best way I can think of to teach you guys how to do some of these problems. So let's take a look at my document camera. We've got some of the questions that they're going to ask you. They're going to give you a standard form quadratic equation. And they're going to ask you to rewrite this into vertex form and then take the inverse of it. Well, remember, in order to get vertex form, you have to identify your A, B, and C. In this case, 1, 4, and 4. And you use the formulas H equals negative B, so negative 4 over 2A. So in this case, H equals negative 2. And K equals C minus B squared over 4A, which in this case is going to be 4 minus 4. Is that right? 4 times 4 is 16. 4 times 1 is 4. 16 divided by 4 is, yeah, so K is 0. Let's go ahead and graph this on Desmos. See if I can find an open Desmos. And let's see if this will pop up Desmos for us. It will. So graph. We're going to graph x squared plus 4x plus 4. As you can see, our vertex is at negative 2 comma 0, which is exactly what our, that is not very well focused. There we go. Which is exactly what we found out on our document camera. Our A value is 1, so we get f of x equals square root, or not square root, parentheses, x minus h, so minus negative 2 is plus 2 squared. So that is our function. They've asked us to take the positive square root inverse of this. So if I have f of x equals x plus 2 squared, we're going to go through the 4 steps that we learned a couple days ago. Change this to y. Forgot the squared. Switch x and y. And then we need to solve for y. Well, the opposite of squared is square root. Opposite of plus 2 is minus 2. So that tells us that the positive square root function, the inverse positive square root function, is this. And this fits that data to what we're looking at. So let me show you what I'm actually seeing on Desmos, or not Desmos, HRW. Let me fix the sizing here. I'm going to have to scroll that down, and we can read all of this. So, quadratic function in vertex form, that was the first thing we found. It was x plus 2 squared. Vertex of f of x is negative 2 comma 0. The inverse positive square root function That's the last thing that we came up with, which was square root of x with minus 2 on the outside. The initial point of the inverse is going to be 0, comma, negative 2. You can do that because the vertex of f of x, if you just flip those two, negative 2, 0 becomes 0, negative 2. The x and y coordinates of the vertex are switched in the initial point. Maru? Let's go back to Desmos real quick. Square root x minus 2. Y equals x. That is clearly the correct I don't understand what issue they have here on the HRW assignment. Let's see. I really, truly don't see what they dislike about what I've got here. Because, oops, that's supposed to be plus. Oop, not 21, squared. Basically what I'm doing at this point is I'm just making it so guys, this is one of the reasons why I sometimes dislike HRW. You know how I've always told you that, you know, if it's adding 0 at the end, you don't need it? Well, they changed their mind. They say you need it. So, yeah. That is dumb. Hopefully you will recognize that that is dumb. And I apologize in advance. So let's keep going. Domain of f of x is restricted so that its inverse is a positive square root function. The interval form is the domain of f of x is restricted so that its inverse is a positive in interval form. Oh, they want us to restrict it, but they want us to give that in interval form. So that's going to be negative 2 is the smallest x. Remember, you're taking the x value of the quadratic, and that's going to be negative 2 up into positive infinity. Don't forget that it can equal the negative 2, but you can never equal infinity. The range of f of x in interval form is 0 to infinity. The domain of the inverse is 0 to infinity. Notice on Desmos here that with the inverse, our domain, the furthest left it goes, is this vertex point, and that's 0, but it keeps going. And then our range is going to be negative 2 to infinity. So I know I need to scroll down a little bit here. Actually, you guys just can't see the bottom. So we need to make this a wee bit smaller so that I can pull this down a little bit more. There we go. All right. The range we just said was going to be a negative 2, comma, infinity. And the domain of f of x is the same as the range of f inverse, and the range of f of x is the same as the domain. We actually talked about that when we talked about inverses, that if you reverse them, you get just that. A graph of f of x is a transformation, and we talked about transformations so much yesterday. So this is a three-part problem. It's not too bad. This question is literally the exact same as the previous one. This question is where you guys might start having issues. I hate this question. I'm not going to lie. It's horrible. Part of it is good. You know, initial point. What's the first point you see? 15.4, comma, 7. Easy. Which of these graphs starts at 15.4, comma, 7? Well, this starts at comma 8, this starts at comma 9, this starts at comma 7, this starts at comma 6. So we know that this is C. Here's the problem though. They ask you to give them the estimated square root function. Now you guys know that a square root function has some number a, square root, x, plus or minus h, and then on the outside, plus or minus k. Luckily, most of these you guys already know how to do. You know that h is the x value of the vertex. Well, the vertex, in this case, is 15.4, the x value for the vertex. So this is going to be minus 15.4. This is going to be plus k. In this case, the vertex is at 7, so plus 7. What you don't know how to calculate yet is this a. I've shown you how to do it, document camera, where you take the y value, sorry, not y2, the y value minus k divided by the x value minus h. Now, when we were doing this with a quadratic, your reference chart has this in parentheses and says squared because we were doing it with a quadratic. But this isn't a quadratic, it's a square root. So we're actually going to put the square root sign there. Slice it by a piece of cake. Here's the problem. We know h and k. What we don't know is what second point to use. And each of these 4 different points, when used as a second point, gives us a different answer. So which one should we use? The answer is look at the graph. Which one of these points comes closest to the line? Well, clearly it's not this last one, and this one looks closer than this one, but this point and this point look about the same. I would always use the one further away from the vertex that is still close to the line. So I'm going to use this one. It looks like it's at about 17-ish, comma 10. So let's see what that is. It's actually 16.2, comma 10. So I'm going to say 10, 16.2, square root on the bottom. My k, we already said, was 7. And my h is 15.4. That gives me my a. So if you were to do this, 10 minus 7 is 3. Now, I don't have a calculator on me, so I can't really do this. I could do it on my computer's calculator, but I'd be robbing you of the fun of figuring this out. And that's just wrong. But if you take 16.2 minus 15.4 and then take the square root of that, 3 divided by that, here's the other thing they don't tell you. What do they want you to round it to? How are you supposed to know? 2 decimal places, guys. That's what they want. 2 decimal places, the nearest hundredth. So in this case, I believe it ends up being 3.35. Let's see if that's right. If that's not right, I'll go ahead and do the math for you guys. That's not right. Okay, I'll pull up a calculator. This is just for you guys, though, because you all are amazing. So 3 divided by, parentheses, 16.2 minus 15.4, close parentheses, square root. 3.35. That's what I put. It's 3.35. And they said it was wrong. Did they only want it to? Oh, no, I know why it's wrong. The other problem is they're not using x and y, guys. They're using b and a. So instead of having x in the equation, I should have b. I knew that, and I failed. But notice that it's not just a lowercase b, it's a capital B. You put the wrong one in there, it's going to tell you you're wrong. So 3.35 times the square root of b. Keep in mind what they're asking for. This question is basically the same, except they at least tell you what to use as the second point. They tell you what point to use. 5 and 6 both ask you to use a graphing calculator. So you're actually going to use the steps from last unit when I showed you how to do this on a calculator. But look at this. See how this says y comma x? They actually want you to plug this stuff in backwards. So what they're having you do is they're having you do a quadratic regression for y comma x. So plug these in as though they were your x values, plug these in as though they were your y values, and do a quadratic regression. Then do the inverse, and that gets you your square root regression. Now, why are they asking you to do it this way? That doesn't make any sense. If you look closely, you'll see that the TI Nspire has a lot of different types of regressions, but it doesn't actually have a square root regression. So they are basically using a clever method of math to trick the calculator into doing a square root regression using inverse functions. Is it roundabout? Yeah. Does it suck and take way too much time? Also yes. But is it a clever application of problem solving and the exact type of thing I'm trying to teach you? Yes. So on this problem, you're basically going to do the steps for finding a quadratic regression, but you're going to plug the y values in as the x values and the x values in as y. You'll get your quadratic regression. That's going to be in standard form, and we don't want standard form, they want vertex form. So you'll then have to convert standard to vertex, and then they're going to want you to give them a domain and range. Notice that domain and range are backwards here though because of what we're doing. Domain is going to be on the y-axis, range is going to be on the x. They're then going to have you find the actual inverse to give them the square root regression. So guys, I know this section is kind of weird and very different from anything we've done in the past. Please ask if you need help. There are only 6 questions here. I know you guys can do them, but it is much more problem solving than previous sections. I like this for that because it makes you guys use your brain and not just go 2 plus 2 equals 4. I don't want you to be able to regurgitate. I want you to know how to do these problems. So I'm sorry this video ran so long, but hopefully it gives you the basis for what you need for 6.3. Good luck.